Math jokes are awesome.
When they're like about
I got an excellent, I haven't participated in faculty follies in many years, but I got an excellent idea of something I should do this past weekend. So hopefully I can keep it a good secret because it'll be phenomenal. You would not want to miss it. Huh?
Don't talk about it because it's recording.
Oh, it is recording, but I'm not going to say what it is. I'm going to keep it a secret. All right, so did that give y'all time to create this?
No.
That means they got greater than 6 hours of sleep.
The first one? The first one's less. That's a less than symbol. Put your left hand up and you tilt it sideways. It makes less than. Left hand, less than. Left hand, less than.
98 people out of 20 get more than 6 hours of sleep. That is ridiculous.
I'd be lucky.
Why is it 10 over?
Yeah, I get like 4.
6 hours of sleep is like when you wake up in the morning and the birds like
6
fly.
hours
Vince
of
Willoughby,
sleep.
why is it 10 over 12 in the second?
Yeah, it's like they cut commercials from the weekend.
Because I got interrupted.
For you.
So you divide everything by 120?
Yep. All we did was divide by 120. Okay, that's fine. There's one main reason why we made the table is just so I could remind you of some things. So this is our relative frequency distribution, and sometimes you're actually given the relative frequency distribution instead of the frequency distribution, so you really should be able to use both of them. Now, when we're looking at the relative frequency distribution table, do y'all remember what the information in here is called? These are called what?
I remember.
Those are our joint frequencies. Do y'all remember that?
Yeah.
These are our joint frequencies. So if they're inside the table, if it's this and the other, so this would be the frequency of somebody getting less than 6 hours of sleep and pass the test. That's a joint frequency. This and the other together. Joining, joint, and. Got it? Okay. Versus. Does anybody remember what we call the ones in the margins?
Toggle joint.
Marginal. The ones in the marginals we called marginal frequency. Doesn't it? So these were our marginals, the ones in the margins. Those are our marginal frequencies. So that's just a reminder from last year. And of course, since I've circled it on this chart, these would be marginal relative frequencies and joint relative frequencies, because I circled them on the relative frequency chart.
You should make your own color.
Okay, so A says to the nearest percent, which is odd, because usually when we deal with probability, they want all of our answers in terms of a fraction or a decimal. But this says percent, so we'll answer it in terms of percent. To the nearest percent, what is the probability that a student who failed the exam got less than 6 hours of sleep? Okay, do you see this little statement here? A student who failed the exam. Does that sound like a condition? So that turns this into a conditional probability, doesn't it? And when we look at a conditional probability, we would write it like this. This is the probability that we got less than 6 hours of sleep. I should probably write that sleep. There we go. Sleep less than 6. Given, what's our condition? What's the given part? That they failed the exam. So you should be able to understand these words, or if I gave you the symbolism. If I wrote it like this, you should know this means the probability that we got less than 6 hours of sleep given that we failed the exam. And when we look in this chart, we're going to look at the failed the exam row or column. Do you see this is my failed the exam? Okay, so when I look at my failed the exam, how many got less than 6 hours of sleep? 10. Out of how many people failed the exam, because that's our condition, 18. And 10 divided by 18 is approximately what? 56%. 56%. Now, when we have this joint probability here, when we have this conditional probability, use the wrong word, conditional probability, if we were to look at the formula, what we do is the probability of sleep less than 6 and failed exam over the probability of what? That they failed the exam. So if I went to this relative frequency, if I did the probability that less than 6 hours sleep and failed exam in that 0.083, divided by the probability that they failed the exam, 0.15. Calculators, please. What is 0.803 divided by 0.15?
5.35.
0.55. Would it round to 5.6?
No.
If we could put in the 0.3 repeating, guess what it would round to? The exact same thing we got just a second ago. So this leads us to our definition. When we have this conditional probability, it's the probability of A and B over the probability of the given. Well, it's nice when we have a two-way table, isn't it? Because we don't have to go back to this definition, but we're going to go back and forth between these two. Okay, B. To the nearest percent, what is the probability that a student who got less than 6 hours of sleep, does that sound like a condition?
Yeah.
That sounds like a condition to me. Failed the exam. So now we're looking at the same two things, but in a different way. This time my condition is, got less than 6 hours of sleep. I'm looking at that row. How many failed the exam? 10. Out of how many? 22. And 10 divided by 22 is approximately 45%. So this says student failed the exam, got less than 6 hours sleep. This says got less than 6 hours sleep, failed the exam. So did we get the same thing?
No.
So is this true? The probability of A given B, is that always equal to the probability of B given A? No, it's not. And do we know that this bar means given?
Sure, no.
Yeah. All right, so those are, I should have put the not equal to in there for those of you that are watching it. They are not equal to each other. Okay, C. To the nearest percent, what is the probability that a student got less than 6 hours of sleep and failed the exam? Is this conditional? No. It's just this and that. So, how many did less than 6 hours and failed the exam? 10 out of 120, which we already had on here, didn't we? 8.3%. We actually never put a repetend in there, so it's 8 1/3%. Sorry. We would never put a repetend with a percentage. 8.3 repeating would be 8 1/3%. Okay. All right, let's go back to part B. How would we write this as a probability? What would you write? The probability of what? If you were to write this symbolically, how would you turn this? What would it look like? The probability of failed exam given line sleep less than 6. So, if we looked at the formula, it would be the probability of failed exam and sleep less than 6 divided by the probability of sleep less than 6. Okay. Next problem, number 2. It's a two-way table. What's missing? The two-way table. Man. Let's make one. All right, so a botanist studied the effect of a new fertilizer on 100 orchids, giving 70% of those plants fertilizer. Of the plants that got fertilizer, 40% produced flowers. Of the plants that did not get fertilizer, 10% produced flowers. Find the probability. What are my two variables? Fertilizer and no fert. That's one of them. So one has to do with fertilizer. What's the other variable? Flowered or did not flower. Good. Flower or no flower.
Oh, Miss Goldman?
Yeah.
Can we do this in a different color?
Sure.
I can't see red.
Oh.
Did you just be mean? Don't be mean.
Oh,
Is that better?
thank you so much.
All right, total. All right, so how many plants? What's our total? 100. How many got fertilizer? 70, because it's 70%. We've got 100 total, 70% got fertilizer. So how many didn't get fertilizer? 30. Because 70 plus 30 is 100. Okay, next sentence. Of the plants that got fertilizer, 40% produced flowers. So what's 40% of 70? 28. Guys, what's 4 times 7?
28.
Yes, 40% of 70. If you just move the decimal one place this way, move that one back one place that way, it's 4 times 7. Yeah. All right, so what does it leave for right here? 42. Okay, next sentence. Of the plants that did not get fertilizer, 10% produced flowers in a month. So something's 3. What is it? Flowers. So do you now see how we can do it? If this is 3, what is this? 27. If this is 28 and 3, what is this? If this is this is
69.
All right. Now, could you answer questions now that you have the table? Sure you could. Let's move on.
Yay.
Okay. right here. Okay, go ahead and read the paragraph when you get it. That way by the time I get to the front, you're ready to go. Okay, I borrowed this from another teacher from another school and edited it to make it Stars Millish, but I didn't catch something on the back, so before we leave, we will do that.
OHS.
Yeah, OHS should be SMHS.
OLA.
Okay. So, a survey of Starsmall High School students found out that 36% said they would be interested in going to Jupiter. Of those that wanted to go to Jupiter, 60% were seniors. Of those that did not want to go to Jupiter, 30% were seniors. Create a tree diagram for this situation. So, the first thing we're going to look at is Jupiter, the probability of going to Jupiter. Well, if we look at that, we have those that want to go to Jupiter and those that do not want to go to Jupiter, right? How many people wanted to go to Jupiter? 36. I guess I could have, hold on. Let me put,
Yeah, how many people did you survey?
so it would be 36%. Thank you.
How many people were surveyed?
We don't know. We just know the percentage. So this would be not Jupiter. Does that make sense? Now, then the second part they gave us were seniors, right? Okay, so we have those that are seniors. That go to Jupiter. And we have the seniors that, the not seniors that want to go to Jupiter. I guess I could say others. So, how many seniors? Oh, it didn't tell us how many seniors wanted to go to. It just told us how many that were not seniors. So this was 0.6. So what does it leave for here? 0.4, because it's the complement, right? Okay, then we have seniors that do not want to go to Jupiter. And we have not seniors that do not want to go to Jupiter. Okay, so it told us there were, of those that do not want to go to Jupiter, 30% were seniors. So where's that 30% go? 30% are seniors, so it goes here. And so what does it leave for not seniors? 70%. Okay, does all that somewhat make sense? Okay, now from this, we can find the probability of being a senior and going to Jupiter. So it's the probability of the Jupiter times the probability of being a senior going to Jupiter. So it would be the 0.36 times the 0.40, because this is conditional. We have to satisfy the first condition first. So the probability of this and this, we're going to multiply those. So what is the probability? 0.144. Okay, what is the probability that they were not a senior and wanted to go to Jupiter? What would it be? 0.36 times 0.6. So that probability is 0.216. Now we can find the probability that they were a senior and they did not want to go to Jupiter. Would be 0.64 times the 0.3. 0.192 versus the probability that they were not a senior and did not want to go to Jupiter, which is 0.64 times 0.70. 0.448. Now, what beautiful thing happens when I add up all those numbers? It equals 1. It is magical. So, what is the probability that a randomly selected student wanted to go to Jupiter? So I'm just looking at the probability that they wanted to go to Jupiter. Just Jupiter, nothing else. Isn't that the 0.36?
And we put 36% or 0.36.
Normally, probability is not written as a percentage. The only time I would ever write probability as a percentage is if the question asks what percent. Okay, B, what is the probability that a randomly selected student was a senior and to go to Jupiter? So we want the probability that they're a senior and they want to go to Jupiter.
This is such a great scenario.
0.144. Good. Okay, now this one wasn't given to us. What is the probability that a person is a senior? Now, does it make sense to find the probability of a senior? We could add up the probabilities of the seniors that want to go to Jupiter with the probabilities of the seniors that not want to go to Jupiter. Does that make sense?
Yeah.
That if we added those two individual, so we'd get 0.144 plus 0.192, and so the probability of just being a senior is 0.336. Okay, now this one. What is the probability that a randomly selected senior wanted to go to Jupiter? Now, do we see that the senior part is a condition? So now we are doing conditional probability that a senior wants to go to Jupiter. So, because it's a condition, we would do the probability of Jupiter and a senior that wants to go to Jupiter, and the and divided by what is our condition? The probability of being a senior. So,
And why is that a condition?
when it's a conditional statement, this is the probability of Jupiter given senior. It's the probability of, we did the probability of A given B is the probability of A and B divided by the probability of B. It's the probability of the intersection divided by the probability of the condition. The intersection divided by the condition. So, this would be 144 divided by 0.336, and do you get 0.429? Okay. Last one on here. The probability that randomly selected Jupiter wannabe was a senior. So we have another condition, don't we? The Jupiter wannabe. So it's the probability of a senior and a Jupiter divided by the probability of Jupiter. So it's 0.144 over 0.360, and that's 0.40. Now, what we would do in the next step is we would take these and fill out this chart. I'm going to finish this lesson. Those of you that need to hear it can listen to it. This part's easy. The back of the worksheet and the book problems are your homework. The back of the worksheet and the book problems. Okay, I'm going to finish up the lesson real quick. Now, all this data on the two-way tables we can get back up here from our tree diagram. So if we look at our tree diagram, the probability of a senior and wanting to go to Jupiter was 0.144. The probability of a senior and not wanting to go to Jupiter was 0.192. So when we add these two together, we get 0.336. The probability that it was not a senior but wanted to go to Jupiter was 0.216. The probability that they were not a senior and did not want to go to Jupiter was 0.448. And so when we add these two together, we get 0.664. When we add going down this column, we get 0.360. When we add going down this column, we get 0.640. And if you notice you add across and across, you get 1. Now this says if 500 students were surveyed, fill in the two-way table. Well, all we're going to do is take these probabilities and multiply by 500. So that gives us 72, 108, 180, 96, 224, and 320, 168, and 332. And that's it.